my name is Ashley, and today I'm going to be giving you guys a brief presentation on a couple different factors that influence wildfire behavior. So the three principal environmental elements that affect wildfires are weather, topography, and fuel. I'm going to be going into each one of those categories a little bit more into detail for you throughout the presentation. So first I want to start with weather. Weather is important when it comes to fire behavior. If you don't understand the predicted forecast, then you're going to have a harder time predicting what the fire is going to do. And ultimately, this will cause difficulty when it comes to developing an effective suppression plan. The most important weather components that influence fire behavior are wind, relative humidity, and temperature. Wind is defined as the horizontal movement of air. So wind has the greatest impact on fire behavior of any of the other weather factors. So ultimately, the stronger the wind, the faster the fire is going to spread. So when we think of fire, we know that fire needs three different things: fuel, heat, and an oxidizing agent, like oxygen. Can anybody tell me what wind brings to the fire?
Oxygen?
Yeah, it increases the supply of oxygen and thus aids in the combustion process. That is one way that wind affects wildfire spread. The more oxygen that is supplied to the fire, the bigger the fire gets and the faster it's going to spread. Other ways that wind affects wildland fire spread is it bends the flames and preheats the fuels that are in front. It can also blow embers to other areas and start spot fires. So an example of this would be during the Waldo Canyon fire. If you look at some of the aftermath pictures of neighborhoods that were affected, like the ones that I sent you guys online, you could see that some of the neighborhoods, there was only one or two houses throughout the entire neighborhood that were burnt down. These were likely caused by embers. Wind also influences the direction of fire spread and spot fires. It carries away moist air and replaces it with drier air. So ultimately, where does wind come from? Well, wind is a result of solar radiation, or the sun, that's heating the Earth's surface. So if you think of different places on Earth, each spot heats differently, and this causes uneven heating to occur. So when uneven heating occurs, it creates an atmospheric pressure difference that's called pressure gradients. So winds are produced as air from a high pressure area moves to an area of low pressure. So the greater the difference between the two pressure areas is going to be a result in stronger winds. So wind direction is determined by the locations of the high pressures and low pressures. Remember again that the winds are produced as an air from a high pressure area moves to an area of low pressure. Wind can play a significant role in fire behavior. It can not only aid to the fire's overall growth, but it can also change the fire direction, which can make the fire unpredictable at any times. So when we think of relative humidity and temperature, they kind of go hand in hand together. So temperature is defined as a degree of hotness or coldness that is measured on a definite scale. The temperature of air is directly related to how much moisture the air can hold. When we talk about relative humidity, it is the moistness or the dampness of the air, or how wet or cold, or wet or dry the air actually is. The moisture in the air has a direct effect on fuel moisture and fire behavior. The hotter the air, the lower the humidity. The hot air draws the moisture from dead fuels like leaves and lowers the moisture content of those fuels. As the temperature goes up, relative humidity goes down. Firefighters must know the difference between relative humidity and temperature in order to understand or predict fire behavior. Let's now go on to topography and its effects on fire behavior. So the definition of a topography is it's the configuration of the Earth's surface including the position of its natural and man-made features. So it's pretty much the layout of the land. Topography affects wind patterns as well as fire spread. The most important components of topography that influence fire behavior are the steepness of the slope and aspect. So the definition of a slope is the degree of incline. The slope on which the fire is burning is a major factor in the rate of spread. So if you take a look at my model, I have a couple different slopes here with pine trees. So it's supposed to resemble a forest. So slopes contribute to preheating and ignition. So as the flames and heat rise upward. So if you just think of them going up like this makes the fuels that are higher up on the slopes easier to ignite. So the steeper the slope, the closer the fuels are to the flame, or to the flames on the uphill side of the slope. This allows the fire to spread faster throughout the forest or the different slopes. Fires spread slower when they're going down a slope because the fuels on the declining slope are positioned below the flame front and are further from the heat. Slopes are dangerous to firefighters, especially if the firefighters are located below the slope, because burning material can roll down the hill. So aspect is the direction of a slope, or is the direction a slope is facing. So the orientation of a slope to the sun determines the amount of solar radiation that reaches the specific surface of the fuel. So the aspect is fixed, and that means that it does not change. But the solar radiation, or the sun, does change as the sun's position changes throughout the day. The aspect and time of day influences the flammability of fuels. So due to the long amounts of solar radiation received during the hottest part of the days, those fuels are easier to ignite because they are warmer and drier, and it lowers the moisture content. So again, if you take a look at my model, you can see that I have labels for north, south, west, and east. So, like what we just talked about, the fuels the south aspect are most vulnerable to the fire. This is because they are ultimately getting solar radiation during the hottest part of the day. So aspects, you can think of, so if the sun is my hand and it's pointing down, the side on the east side is getting much more solar radiation than the west side. And as the sun moves throughout the day, the aspects change, and different areas and different fuels get heated throughout the day. So speaking of fuels, the definition of a fuel is a material that burns and produces heat. It is a material that is burning or a material that has the potential to burn. So on my model, it's the trees. The trees, the grass, the brush, the forest floor, all those are fuels, considered fuels. The most important fuel components that influence the fire behavior are fuel moisture and temperature. So the warmer the fuels are, the less heat that is needed to ignite them, making it easier for ignition to be possible. So like what we went over earlier, fuel temperature is changed by solar radiation. Fuel moisture is the amount of moisture in the fuels that will affect how easily the fuel will ignite. The less moisture in the fuel, the easier it is to ignite. The more moisture, the harder it is to ignite this fuel. So wildland fuels are commonly divided into two main groups. So you have your light fuels, which are your fast burning fuels, and your heavy fuels, which are your slow burning fuels. So I'm going to go into each one of these categories a little bit more and further in depth for you. So the light fuels, they're easier to suppress, but they are also easier to ignite. They also can move extremely fast and burn with significant intensity. Light fuels are responsible for a high percentage of firefighter fatalities because they go underestimated. Examples of light fuel are like dry grass, dead leaves, tree needles, like the pine trees on my model, brush. Some of the green fuels, like the tree needles and other brush types, have high oil contents, which makes them more prone to burning extremely fast. So when we talk about, or when we go into heavy fuels or slow burning fuels, they are fuels that burn readily and produce large volumes of heat when dry. They are also much harder to suppress, but therefore they are much harder to ignite as well because of their surface area. Examples of heavy fuels include logs, stumps, branchwood, or deep duff. And deep duff is partially decomposed organic material that's located on the forest floor. So if you think of walking down a forest and you look down at the ground, you're gonna see a litter of twigs, leaves, and needles. The deep duff is the layer that is beneath that material. So based on the information that we have gone over about fuels and temperature, which do you guys think would ignite first? The light fuels or the heavy fuels, and why?
The light fuels because they're heated by the sun faster.
Right, correct. It all depends on the location of the fuels, whether they are considered to be light or heavy, and their moisture content, and how long they've been in contact with the solar radiation. So a fuel that has been in the sun for a long period of time obviously has less moisture content and is therefore more prone to igniting, or is closer to its ignition temperature. So looking at my model again, what fuels do you see on the model? And are they considered to be light fuels or heavy fuels?
The pine tree needles and the dry grass would be a light fuel.
Correct, yeah.
The timber and any logs that are part of the tree would be heavy fuels.
Correct, yeah, spot on. So the pine trees would definitely be considered to be light fuels. So when you think about your fuels, you have your ground fuels, which are the deep duff, like what we talked about before, and the roots. You have your surface fuels, which are the grass and the forest floor, or the forest litter. And then you have your aerial fuels, like the tree crowns, and they are the fuels that need to be considered when fighting wildland fires. So just a brief description of an aerial fuel. So when you look at the tree, an aerial fuel is going to be any fuel that is 6 feet higher or above. So, probably maybe a little bit higher than the trunk of the tree, and everything from there up is considered an aerial fuel. And the overall, just the top halves of the trees are the crown, the tree crowns, and they also play a significant part when it comes to aerial fuels. So picking up on changes in wind and weather, knowing the topography that is involved, and knowing the types of fuel that are present are important to consider when developing a suppression plan. This was just a brief interview of some important factors that influence fire behavior of wildland fires. I hope this information was somewhat useful for you guys and helpful, and I definitely look forward to seeing everybody else's presentation. Thank you.